All right. With that, it's my pleasure to introduce Dr. Vladek Miner from University of Virginia. And he's going to talk about structural biology response to biomedical threats. Slide is good, Vladek.
You need to unmute.
Yeah, I'm not hearing anything, Vladek.
Vladek, you need to unmute.
Okay, I'm sorry. Do you see my slides?
Yes.
Yes, and you hear me.
Yes.
Thank you for
Oh,
opportunity to make a presentation with this great session or transaction session. And I'm really scared after all this talk how I will do. And maybe I start to think about retirement. So what is the situation now? We have really crisis, or some people are saying that we are at war with a virus, which we didn't have at least for 100 years. And what I found some time ago, it was a paper that the crisis is a really terrible thing to waste. Yes, because normally we are talking about the revolutions after revolution, but most of us have a tendency to do what we were doing before. And there is no interest really in change and progress, since prosperity is generally equated with stability. But if we have crisis, there is the crisis is a challenge to business as usual. And we have to do something new to really deal with this. And it happened before. Yes, that during Great Plague, Newton was sent to home, and he called these 2 years the years of wonders. And he worked on calculus, optics, and they claim that apple tree is just here. And what is the situation now? If we look into PubMed, we have over 145,000 papers which have SARS-CoV-2 or COVID-19 in the title. We have over 1,000 structures in PDB and over 4 billion hits in Google for COVID-19 and SARS-CoV-2, 290 million hits. So there is tremendous amount of data, not necessarily information. And normal person cannot deal with that. Even people who are very skillful in artificial intelligence, they really cannot deal with this amount of data. So what is the situation, really? We have vaccine, or I should say we have vaccines, but we have still limited medical and limited virus knowledge. We have 197 million cases and 4.2 million deaths. So we are in terrible situation. And what's worse, that the number, and red is US, the number of cases is growing. And why it's growing? We all know here that people do not want to vaccinate. Why? Because many people are getting their news from biased sources, and misinformation has led to skepticism of the scientific community and its motives. And in fact, we are at fault. We failed to produce, we scientists, failed to produce a single message that even high school dropouts can easily understand. And I was thinking what I can do to convince some of people whom I know to vaccinate. And at the beginning, I made this type of curve where I put states. Here are 50 US states. And here we have a fraction of fully vaccinated people. And new cases in the last 5 days, this was made Friday, the week before. And as you see that it's going down here, but here there are also states which have very low number of cases despite of 40% of vaccination. And this is quite often used by skillful and charismatic, but not very smart news anchors. But so I was trying to see whether maybe it depends on the number of people per square mile in various states. And basically, there is some correlation, but Florida is here. And I think that the only explanation which I can find, that if we have vaccination below 55%, there are many fractions and many factors which affect the number of new cases. But if we are above 55 or 60%, there is only one factor: vaccination. And I think if somebody can find something better, it would be great. But I have to say that since I showed that, and I did that 1 week ago, since I showed that to few people who didn't want to vaccinate, they told me that I convinced them and they vaccinated in last week. So I would like to go back to our field, although all of that is our field. Crystallography or structural biology is a part of science, which I think is extremely important for not only for science, but for our life. And if we will look at what has happened with structures, and this is the number of structures from in the PDB by release date, the first structure was done by Zicherao 1 month after we have learned about COVID. And the structure was released. And you see that if you will look here on the lower plot, what is the time between from data collection to deposition, or even from deposition to release, we have to wait on average 2 years. So with my colleagues, with my great colleagues, we started to look whether these structures, which are made very, very fast, are really well validated or well done. And we created the COVID-19 bioreproducibility.org web page, where we are putting all structures which are related to COVID. And we publish a number of papers, and we were trying to use various things to find the whether the structure is perfect or less perfect. And I would like to report to you that tremendous number of structures, very high fraction of the structures are very, very good, despite of this enormous speed. And here you have a paper, but I am putting this last paper. It was done in 2019 when nobody knew about that, but we started to use artificial intelligence or machine learning for ligands to find whether the ligand is correct. And these are the possible corrections. And we divided them into minimal, moderate, or significant. And significant are only two. One is biologically relevant correction, and wrongly model or misidentified primary ligand. I mean, primary ligand which is in the active site, although we have learned that we may affect the function even if ligand is not in active site. I do not have time to go further for that, but we also found in one paper something which is very, very important for PDB. We note here we note that in some X-ray structures of the ligand-free MLPRO, 3CL MLPRO from SARS-CoV-2, obtained at 100 Kelvin, this potentially crucial molecule is absent. They are talking about catalytic water. So we look into the structure, and it's missed from the model. It's not missed from the map. So this catalytic water was not modeled. The map was there. So we look into PDB-Redo, and it was the same. PDB-Redo refined everything better, but didn't put the water which was not there, which was not in the model, but it was really there. So not necessarily you need new methodology. You have to look what you have. Map is extremely important. And sometimes people really do not think about the deposit. And here it's 6Y and Q, 63 authors, and corrected 7 times in 1 year. But still, if you are looking at the B factor, the occupancy, I'm saying not B factor, occupancy of water, you have 0.99, 0.96, which is a total nonsense. Yes, you cannot see that. It's additional parameter to decrease our factor. There is one problem which we have, that do we have important structures? How important are the structures? And these are the structures which waited for author response to PDB for more than 2 months. And you see that if you will look, some of them were COVID related. None of them had sequence, and half of them didn't have even the author and title. But you see that if somebody is waiting more than 58 weeks to respond to PDB requests, it means that the structure is not very important. Yes, and I do not understand that. I have to say that I am old and I do not understand people motives sometimes. And enemy of knowledge. The greatest enemy of knowledge is not ignorance, but the illusion of knowledge. This is Stephen Hawking statement. And you see that there were many people who were strongly against structural genomics. But I would like to say two things. First of all, AlphaFold 2 wouldn't exist without structural genomics. Yes, I strongly believe in that. And it was tremendous contribution to PDB and to humanity. But also we have to use problem-solving approach and integrate structural information with others. And here it was our attempt to integrate the structure of albumin with dexamethasone. And in that time, it was the only drug against COVID, not vaccine, but drug against COVID. And we use medical data, and I strongly encourage you to read this paper. Although some people have doubts why to IUCR journal we would like to push medical data. We absolutely have to do that. We have to have a complete picture. And you see that this is the older paper where we postulated creation of advanced information system, which in such a system, the people who run the system are responsive for data, not the depositors. Yes, and the system would combine information from many sources, not necessarily structural sources. And you will see in IUCR journal again, some attempt of do that for viruses.
Hi, Vladek. You have
Yes,
about a minute.
this is the last slide.
Thank you.
And I mean, not the last, almost the last, toward the optimal response. And these are our recommendations for researchers, for funding agencies, research facilities, and governing bodies. And the one very important is work with the best. Yes, and this is really, it should be everywhere, that collaborate with the best. And I had tremendous luck to collaborate with the best. And these are the people who made contributions, and collaboration with Alex, Zbyszek Dauter, Bernard Trapp, and others was fantastic. And this is something which I enjoyed, and nothing could happen without them. And nothing could happen with PDB. And there is one thing, when we are doing things, we always should acknowledge PDB. They are doing fantastic job. And people do not realize how difficult this job is. Thank you very much.
Thank you, Vladek. That's some interesting observations. Does anyone have any questions for Vladek?
I see Steve and Hanna Domkowska.
Yeah, feel free to unmute yourself if you have any questions. I will ask a quick question. Of the, the many COVID-related structures that was solved. Sorry, I said I was going to ask of the, the many COVID structures that was solved recently. I'm curious, how many of those are EM structures and how many of them are crystallography structures?
You see that you may find that in this paper.
Okay.
Where we put a violin plot, so-called violin plot, which shows the number of structures and resolution. Yes,
Okay.
so you have it depends on resolution, and you have side by side cryo-EM and X-ray structures, and basically we have more X-ray structures with cryo-EM, and they are quite often higher resolution. But we have fantastic cryo-EM structure as well. Yes, I think that I do not think that cryo-EM will kill crystallography. Yes, I do not believe in that.
Yeah.
Or at least it will. I would have to live a very, very long time to see that. But it's fantastic contribution. It's fantastic contribution, fantastic alternative.
Any other questions?
Ray, may I jump in?
Sure.
So Vladek, I want to thank you for a very provocative and exciting talk, and to just provide one piece of data there. I think you're correct that more than half of the COVID-19 related structures in the PDB today are from macromolecular crystallography, but there are 459 structures currently of the spike protein, many of which are cryo-EM. So there's a very substantial fraction in the archive today coming from 3D EM. And these have been particularly important for understanding the variants and the Delta variant, which is currently threatening much of the United States.
Steve, if I can comment on one thing, there are many pan-DDA structures among SARS.
I'm sorry, there are many what?
Pan-DDA structures, which does not provide really new information for, provide new information for a very particular group of people.
Yeah.
But not for.
Stephen, just a detail on that, if I may. Do those cryo-EM structures of the spike protein have anything about glycosylation patterns?
They many of them, Chris, do have the glycans present in the atomic coordinates, not always the complete glycan because of static or dynamic disorder, but certainly there are atomic coordinates for at least part of the glycans in most cases. This allows me to make a plug for the recent completion of carbohydrate remediation, which was carried out by the Worldwide Protein Data Bank. The individual who led this work was Jasmine Young, who's part of the US RCSB PDB team. So we now have proper nomenclature and atom naming for about 15,000 structures in the PDB that contain carbohydrates. All of this remediated information was released last year, and it's proving to be a great boon in this time of the coronavirus.
I see Ania Domkowska had a question.
Yeah.
Thank you very much. I'll put my comment on the chat. I'm very grateful for this talk. I think it's very important that people realize that UCR journals have a special journal right now to deal with raw data collection. I think it is very important, and I think that we should promote it. Thank you, Władek.
Thank you.
Thank you
very much. And thank you, Ray.